Well, it's moving it slowly but surely. So after beating on it, you take the English wheel and then smooth out what I pounded on, make it a little bit nicer. The English wheel is a pretty cool tool because it's got a round anvil down here and a flat anvil here, and that squeezes the metal and then causes the curvature to go with the rounded anvil down at the bottom. So after using the English wheel down at Frank's, I found that it didn't make it match good enough, so I had to just bring it up here and pound on it from the inside with the ball peen hammer to get it to match here. You can see that it's quite a bit closer than it was before, and it has to match up here as well. And you can see there's still a gap. I still got to pound on that. The English wheel kind of helped out, but not enough to push it up against it. It was probably a 1/4 inch or a little more, maybe 5/8 here. I'm going to pound on it some more and see if I can't get it to match. After a couple of more hours of pounding from the inside to get this to match up here, it fits pretty good. The inner fender is off by about 1 inch, and you can see here we've got the space between that line and the tape, and that's about 1 inch. And then I fastened it at the other end, and I need to taper it about how you see the tape going there. And I'm going to have to cut that section out and then weld it back together so that there's 1 inch taken out of there. With the tape draped on there, I'm just going to go along the very edge of this and get a reasonably nice curve. I placed it back on the car, and you can see that curve is reasonable. We'll see how it works out, but I have to make up that distance there between the two outer lines, between here and here, and then that has to fit back in there. Now with that pilot hole cut there, we can hopefully start cutting. Now I've cut most of that section out of there, and it tapers down real nice, and hopefully I'll be able to pull that in and weld it. In order to finish the cut, I have to use the Fordham machine. Now I can move that together little by little and just weld. I'll put a little spot weld there and weld there, and then just keep pulling that together little by little. Well, the welding is done to this point, and now I'm going to clean it up and we'll see what it looks like when I'm done. Cleaned the weld up as good as it needs to be. It's going to be underneath everything, so it doesn't matter that much. So I was a little bit disappointed with taking the undercoating off with the wheel and the wire wheel and the grinder, so I decided I was going to try this. I got my Frank's heat gun here, and we'll see how that works. After about oh, I don't know, 4 or 5 hours of scraping and then going back with the wire brush. I got it so that it's pretty cleaned up. Yesterday I tore this apart. Got the door all apart, window, glasses here. Here's all the guts, the regulator, the sashes, and there's a locking mechanism over there. Gonna clean that up and then get it ready to be sandblasted and then put it back together. I removed the drive shaft and now I'm gonna try to attempt to remove the differential. Differential on the jack. We're gonna see what happens here when I lower it. Now I can take these and bring them to the shop and get all that rust off of there and repaint them. Unfortunately, there are a couple places that the rust was so bad it went all the way through. You can see here. That is just Swiss cheese. So I'm going to have to put a little patch on the back side of that and lead the other side. So I've got this right here. I'm going to put on top of that and just tack that down, and then I'll use the TIG welder to finish it off, but I'm going to tack it with the MIG welder. So far so good. I'm going to start going in between each of those with some more welds. After I welded that plate on the back of that, it's now double thickness right there where that used to be all Swiss cheese. So now what I can do is go and fill that with lead and then smooth it all out, and it won't be recognizable. Now that I have gotten that front part of that fixed, where the signal goes, the turn signal, I can now concentrate on this piece here, and I'm going to cut that section out of there and try to match that with the patch that I have. With the Swiss cheese now cut out of there, I can cut that other patch piece over here, and I've got it marked on here just slightly larger than I need it to be. Now that I've got that cut, I'm going to match it up with the fender and we'll see if it matches the other part. Unfortunately, I measured correctly for the width from here to here, but not correctly there to there. I had to put in, you can see that little piece in there to fill in because it was too short. After a fairly steep learning curve, I took the fender after I put the patch on it. The weld was not a real wonderful weld. It's going to need some serious leading, but it's there. It's solid. Getting ready to finish out the fender here, I've got a piece of metal I bent to kind of match that support metal there, and now it's ready to be welded. So far so good. I've got to now make a little trim here along that line so that I can tuck this in like it's tucked in here. While I was attempting to fix a couple of little pinholes, I inadvertently blew through and completely destroyed this section. So I had to build a little patch And now I'm gonna weld that in place, and hopefully I'm butt welding it this time instead of lap welding it. It should work, hopefully. I learned a lot from the last patch. I learned that MIG welding and a lap weld is not as good as a butt weld, so I made this match pretty darn good. And I'm going to use the TIG welder because I can control that better. So far, it's looking way better than when I was using the MIG. I can get much smaller beads and there's almost no warpage. It's looking pretty darn good if I can just keep going without making a big old mistake or blowing through. I finished the welding and now I'm going to keep working on the finish here. Not sure how much finer that needs to be. Been pounding on it and kind of getting it straight. And there's just a slight indent where the weld is, and I should be able to fill that with lead. After cutting the this piece off, you can see on the back here how he drilled and drilled and drilled and just put the putty through the holes. The damage on the quarter panel here is pretty bad, but not nearly as bad as it was on the other side. On the other side, the inside metal was completely shot all down in here. I had to completely replace that. This that's all just surface stuff, and it still has structural strength. And the back end of this quarter panel here, the damage is just as bad or worse than on the other side. As I did on the other side, I'm going to have to completely redo this piece down here and completely make a new panel for that, so that then has the structural strength where it needs to be. Here are the remnants of the bee colonies that decided to take up residence behind the quarter panel. I learned my lesson early on doing the other fender, and so now I make the pieces so that they actually fit exactly where they're supposed to be welded in. Both patches are now done. The bottom one here, I'm going to have to work on a little bit more. I did the top one here quite a bit more, and it's pretty much ready for leading. I'm pretty sure. After wrestling and pounding and bending and cajoling, I finally got this piece to match up, and I welded in that last little piece, and there it's done. What this does is makes the surface coated with the first layer of lead. This is flux and a bunch of other things, acids, that allow the tin to stick. Without it, the oxides would form on the surface of the steel and then it wouldn't work. So you need to have this. Now that the whole area is covered with a thin layer of lead, they call it tinning for some reason. I guess that's because they used to use tin and lead together. Anyway, you get big lead sticks like this, and then use this paddle with a little bit of paraffin on it, and you place the lead exactly where you want it and kind of spread it around and smooth it as best as you can, and then you go back and file it. So you heat it up till the lead melts. You can see where it melts. You can see it start, and then you start rubbing the stick of lead on top of it and filling in. You keep it so that it's just barely melted. And you can smooth it reasonably well. Once you're satisfied that you've got enough lead on there, you take one of these really rough files and smooth out as best as you can. This area is looking pretty good so far. Gotta keep working my way down.